Hey everyone. Scott, how are you?
Doing good.
Give it a little bit more time. We also have, oh yeah, there he is, Torsten. One or two other people already confirmed it. But I do think that this might shut down after 40 minutes. So not the most optimal, but I think we can keep it within that.
You're saying your Zoom was shut down after 20?
Yeah, I didn't. We were supposed to have like through Miami University. We were supposed to have the or in 40, not 20, but we were supposed to have the. Oh, hold on.
Jack, real quick. It won't let me share my screen, so you might just have to do all the screen sharing.
Here, give me a second. Let me make myself.
FYI, next time we can always hand off one of my Zoom accounts. It's unlimited, so we don't have to deal with that.
Got it. Yeah, I think we set this up with the understanding that it was supposed to be unlimited, and it turns out it's not. We had the link already set, but worst comes to worst, if we're still going by like 37, I can just paste in another link and we can just quickly hop over. Not the most optimal, but all right. I think we've got enough people. We have my co-host, and then we'll just set as host. Awesome. All right. So, Torsten, you want to pop open the?
Yes, sir. 1 second.
While he does that, thank you everyone for coming. This is Miami University Blockchain Club's first technical workshop of the semester, and it is incredibly exciting to have here with us two people from the Truffle Suite team, Scott and Amal, who have very graciously dedicated their time, both right now and beforehand, to help us get this set up. If you guys don't know what Truffle is, it is one of the most popular Ethereum development tools. I'll let Scott and Amal introduce themselves in a minute and talk about that real quick. But yeah. And then my name is Jack Gilchrist. I'm the president of MUBC. And I've got with me Torsten.
Hi, I'm Torsten. I'm the VP of Education at MUBC. Guess we should jump right into it.
So yeah, this is pretty much what we've got planned, and we'll just kind of run through it. Essentially, what we're looking to do is demonstrate how we can build a decentralized application using test-driven and behavior-driven deployment or development, and leverage the Truffle command line to actually do that. Before we go on a little bit, Scott, Mal, do you guys want to say hi?
Sure. Nice to be here. I'm a big fan and a big advocating for all sorts of blockchain societies and clubs. I think blockchain education is incredibly important. Fun fact, there's been a lot more devs being hired outside of college recently than experienced developers. So to know that this is actually not going to waste, that this is actually be very valuable for resumes and whatnot. So that's a little insight on our end, but happy to be here. I work mostly with partnerships and our Truffle University, along with a few other things, lots of hats in a startup. I'll let Amal introduce himself.
Hey guys, I'm Amal Sidama. I'm a blockchain tools engineer at Truffle. I work on most of the tools, and I'm really passionate about onboarding new developers, getting them familiar with good practices, and coming up with ways for them to create a mental model of blockchain development using Truffle and test-driven development. And I'm really excited to see these kinds of communities like yours flourishing. It's amazing. So thank you.
Awesome. Torsten, you want to take it away?
Yeah, sure. So if you guys have taken CSE 201, I know you guys have learned about this. Test-driven development. It basically starts, you write a test case, and it's going to not compile, and because you're declaring an object or whatever.
Torsten, you might have cut out there.
can give him some time to get back on.
This always happens on live demos, even with us. So don't don't sweat it.
Yeah.
This will happen a lot more. As soon as
Yeah.
you go live, that's when you get bugs.
Yeah, I can speak a little bit about test-driven and behavior development while we wait,
Sure.
if you don't mind. Yeah. So the thing about doing this kind of approach to software development is that you have the opportunity to introduce your behavior in isolation. Your behavior is, hey, I want to have a contract that does this, or I want to have something that does this. And then you figure out how are you going to test that behavior in your system, and you write tests. And that's an important part as you learn about your system and you learn how to test your desired behavior. You're educating yourself, you're learning the ecosystem, you're getting to be familiar with the tools. So always start with your behavior, then how you can test it, then watch the tests fail, and then finally gain insight and make them pass. I've been coding for many, many years, and this is always the approach I take when I'm learning a new system, to be able to test things in isolation, make small changes, and then see how it affects the system.
Yeah. Okay. So I think Torsten's internet just died, so I'll just take over. But yeah, that's pretty much the theme of what we're kind of looking to talk about more. So essentially, when we're writing code, right, or tests, we're trying to verify different functionality out of our code, and in this case, that code is smart contracts. So the main part of behavior-driven development is coming up with, in kind of like plain text English, the context, which is, let's take the example of a ATM. If the ATM has $100 in it, and someone puts their card in it, and it's connected to the internet. When someone requests 20 euros, when would be the event? And then the outcome would be it spits out 20. It has 80 left in the ATM, and then it also ejects the card out of the ATM. So we've got the set of the contextual things that are going on that would drive the actual event. We've got the event itself that triggers everything, and then we've got the outcomes we expect to happen, essentially the behavior. So once we've done all that, we can go through, we can write our tests, we can write our code, and actually run it against those tests and examine the code for deficiencies, and go through based off that and refactor that code. And there are a couple of positive consequences that come out of this. Obviously, we can verify the required functionality, but some things that are a little less apparent immediately are that we can also try to expose unintended behavior and ferret out that, as well as trying to highlight parts of your code base that aren't very functional or don't serve any purpose with the actual application you're trying to build. So to actually take it a little further, so some of you guys are probably here because of the supply chain part. And what we have today is an actual application that can be used like in the blockathon, hackathon later, or just for any sort of, let me back in real quick. Any sort of multi-party, chain of custody tracking application that you can think of. This is kind of the boilerplate for that. So the code itself is just kind of like the application we chose was to kind of demonstrate that you can build business applications by using all of this, but we're not going to focus too much on that.
Real quick, sorry about that, guys. My internet just died. Jack, you got it?
Yeah, I can just run through the app, I guess. Just keep going. So we actually go to this application. This is live. You guys can go to it yourselves. A couple of requirements. You do need MetaMask, so you can get that from Brave, or the the Chrome store. If you don't have that already, and you need to get actual Brave Ether, and you can do that by. Let me grab this. So you have to basically tweet out your address to authenticate yourself. So we've got this tweet we sent out earlier about the workshop, got our address in it. If we go actually take it and we put it into the Rinky faucet, we just paste it in, give me ether, take a bunch. All right, it's gonna come on. Alrighty, well, I already have ether, but this doesn't work again. I'm not gonna mess around with it. Yeah, so I have no clue what's going on with this faucet. I used it 30 minutes ago. So if you were to use it and do the same thing, it would absolutely work. I think it has something to do with the fact that I have way too much text in here. But what would happen then is you'll get free ether that'll pop up in MetaMask when you connect to the Reiki network. So that's what we've done. We've got 5 ether here. We need to make sure that our second account, though, because we have multiple parties, has ether as well. So really quickly, we can just go, we can go grab this account, send, let's get it. And that's all the setup you need to actually use the app. Once you've done that, you can go back into the application and step through it. So you can start by, I don't know, let's sell a TV. And this price is calculated in Way, which is the, looks like that big up there. The smallest denomination of ether. You could absolutely tweak this with a stable coin to make a more robust tracking of value across this. But you know, again, this is supposed to be fairly basic. So let's just say we want 1,000. And this pops up, MetaMask says, do you want to make this transaction? We tell it yes. And because Ethereum's slow, we gotta run through it or wait for it. But eventually, because this is Rinky and you know, it is not completely proof of work, it should only take 20 seconds, and now we've actually got our item. So we connected from the first account. We want to have both a buyer and a seller. So we've connected as our seller. Now let's switch over to the buyer. Now we can actually buy this. This wasn't there before if we looked on this, but we can actually purchase this. It will deduct this much from our ether balance. We can actually look at that. I think it should show it in the transaction, but again, this now will mark this as purchased in our internal supply chain app we've built. So we go back again. Waiting for seller to ship. Go back to the first account. And we can see now actually that we can ship this. So because we are the seller of this item, we can say, all right, I handed this off to UPS or whatever would be happening in our proof of concept that we're trying to demonstrate. So we mark it as shipped. And this would kind of, again, denote it going onto a truck and going to the distribution center or going to someone's house, wherever this item is being shipped. And then we can switch back to the person who is purchasing this, who is now receiving this item. And you know, whether they're actually marketing them or marking it themselves, or it's the UPS driver scanning the item as he drops it off at the house or something, that right here will denote that it has been delivered, and all the parties on this application can be fairly confident that it was actually delivered based off of it. Obviously, you can build in more robust systems, but this is just a proof of concept to show kind of the chain of custody for all this. So this is our app. This is not the focus of the Truffle part, though. So we also, again, we have the repository right here, so you can take a look at that. We're actually going to run through this now, but you need shell access. You need to have Node.js installed, npm, Node Package Manager, Git, and then the Truffle npm package. So I can actually really quickly drop a link to something in case you are having any issues, but this really is pretty easy to install. So there's that. But let's actually crack this open. So the first thing we want to do when we're building an actual Truffle project is we want to initialize it. So in order to do that, we're going to have to make a new folder. So let's do, let's see, because I've already got a selection right here. And this is our brand new folder. If we look in it, there's absolutely nothing, which is what we want. So the first thing we need to do, again, you have to have Truffle installed, Truffle init. And this will set up the package or the folder structure and place in all the different files that we need for this to actually work. And as well, we're just going to run, you know, just to show what happens. So we get our contracts folder, which has just a migrations file, which is just internally for Truffle. We've got the actual migration itself. Again, an internal thing to help facilitate all that. Then we've got our tests, which have nothing so far. But let's actually try to build a little bit of this. So what we can do is, or we're going to init real quick. Doesn't really matter. npm I at truffle hd wallet provider and .env. So again, this code will all be provided, or at least all the important parts in this slide deck. But what we're doing right now is we're installing a subdirectory of the Truffle tool, which is the hyperdeterministic wallet provider. This is the insane, like, here is the demo I have. Mnemonic that generates the actual addresses that you would be using. So, and then .env will just allow us to have environment secrets, which is also important. We'll get to that in just a second. So now we've installed everything. We've got our package set up. The very first thing we want to do is make that environment file that we just talked about with .env. So we can do this. If you actually look at example, I think that it includes an example in the actual GitHub of what you need to have, but we can also just do it right here real quick. So bi.env, you want mnemonic equals to grab that. And you should get this out of Brave or something like that. Don't use, like, if you look up mnemonic generator on Google, chances are that is compromised. So, I mean, if you're doing it for development, chances are nothing's going to happen. But if you ever were to use it for anything valuable, it's sweet. So that would be the first one, and then we want Infura. So this is the second part, Infura. Infura is a gateway to allow us to access the actual Ethereum blockchain. So we just need to set up an account on this, which I've already done. Grab the project ID. Again, I'm going to delete this right after. You would not want to expose this. And just drop it in here. Oh, whoops, that's not. Oh, whoops. There we go. All right. So now we've configured our environment variable, but we need to still employ that. And at this point, I'm actually going to pop open VS Code just to make this a little bit easier. Including for everyone to read. So our Truffle config, there's a lot in here. And again, to save a little bit of time, I'm actually going to do a little bit of copy and pasting throughout this. But essentially, the thing that we want to build right now, or set up right now, would be this part, networks. So we are going to need to acquire .config. I think that just grab this one. All right, yeah, and then this. And then so we actually have it as the newest package. So we've imported the two packages that we installed from npm, .env, and the HD wallet provider. Now what we want to do is we want to set up our two different networks, which are going to be development and break for this, we can just, again, kind of dig it. So with the development port, we are going to set this up as if we were connecting to a local network. So host and port, depending on where you decide to host it from, but let's go with the same one here. Again, I'm just gonna grab it. So we're going to be connecting to 127.0.0.1 at port 7545, and network ID actually specifies the Ethereum chain. So when you connect to all these different networks, they all have IDs. So I think the main Ethereum network is like 1. I think these 4. I think the main network might actually have 1 and 2 or something like that. But again, for Rinkby, what we want to do is we want to set the network. Now, actually, let's write the provider ourselves, just so. And we want to return new key wallet provider. And it takes 2 arguments, which are the mnemonic and the Infura URL, which are, again, the 2 things that we put in. So we can access those just through the syntax process mnemonic, and again, and this will allow us to point it at this endpoint with this account. And then we need to still tell it that it is doing the network before. So now we've configured this correctly. You can mess around with this stuff, but we're not going to. And this is pretty much everything that you would need to actually configure Truffle itself. Now we can run pretty much all of the commands that we want to do. So now we actually want to build our contract, and we're not looking to go into specifics about the logic, but what we are trying to do is demonstrate how we can use Truffle for behavioral driven development. So the first thing we're going to do is we're going to create our supply chain.sol file. And let's just quickly move on. That's a lot. So, and again, you know, copy and pasting because we're more focused on how all of this interacts together. This all is a functional contract. This is the contract that we were interacting with on the Rinkby demo on GitHub right here. So if we were to run a test with this right now, it works. So let's pretend that we wrote this ourselves, and perhaps you know, we were a little tired, forgot to actually set the verify caller function, which checks basically whether or not someone is allowed to move a certain item around and mark it as shipped or mark it as sold or something like that, or up for sale. Let's say we just forget to do that, and instead it's just going to mark everyone as okay. It's never going to revert. Obviously, when we actually go to test our application, we are going to say, and to go through it again, let's say the context is if an item has been marked as purchased and the logged in person is not the seller, an event happens where they try to mark it as shipped, then we expect the outcome to be that the transaction reverts and nothing happens. So when we actually go write our tests, which we can also a little more stealing from. And there are plenty, we will have some resources on like writing tests from kind of scratch, where we're more kind of looking at how we can implement all this. So I guess this stuff's a bit too. No, that's used. Yeah, that looks like it's not this actually. This is the main file right here that we're actually worried about. The test helpers, I think, can be right here. So this is used to detect whether or not a transaction fails. So that's why we run that other part. But if we go actually grab this code, this is all here. And to talk about the framework of this a little bit, you may have seen describe and it in like traditional, I think it's like Mocha. So instead of using describe, when you're at the highest level testing a specific contract in Truffle, you actually start by specifying contract. As well, you need to bring in the contract you're testing. So you can do that really easily. All you have to do is call artifacts.require. And this is also done in the migrations file. If you need to import it here, you do the same thing, artifacts.require. But then as long as you have a contract that matches up to .sol, the same exact thing, you can just say artifacts.require supply chain, and it will go and fetch that contract for you. So in order to actually get it working, we can just deploy a new one each time by calling supply chain.new. And because we're testing it in what Truffle calls a clean room environment, it will spin up a new instance every single time and allow it to be tested with no outside influence or kind of tainting of the data. So again, we've got all these different, we've got like our context provided pretty much from here actually. And we've got our event that we're testing. And then we take that result and we throw it in and see if it spits out the correct behavior. Let's actually go and do that. Because we put all this stuff in now, we can Truffle develop. And let me actually go back more. Okay, so this goes into the migration of different smart contracts when you're actually trying to deploy them. This is the part where it actually goes live and it's actually being hosted. So when you do Truffle develop, it's just being hosted locally, and the second you close this, it will go away. But for now, it's going to work. And it should just spin up with a random mnemonic. Yeah. So this doesn't actually matter. We only care about putting our mnemonic into the ENV when we're migrating to a live network, but right now we're still testing. So we've got our tests. Again, we've written them and we've put them in the test file or test folder that Truffle is presented for us in the initialization. All we have to do is test. And this will run, this will build and compile the actual contracts. Okay. All right, so I just switched over. I'm not trying to waste any time. I just switched over to the actual main GitHub version we have of this so that it'll work as guaranteed. So we do actually have to really quickly break this one more time. So what we want to do is supply chain this right here. Oh yeah, it's already done for us. Awesome. Okay, so if we do Truffle develop. Oh, you know what? I didn't put in the migrations, did I? You know what? Yeah, we'll do that really quick. Just so the one thing that we needed to do was add the migrations, because when we run Truffle develop, it's going to automatically try to migrate it. So we did migrate the migrations file because that's in there, but we did not do the supply chain contract. So we can do to deploy contracts.js. And again, you just artifacts.require to get it out. Truffle, when it runs this, will pass in, you always have to pass in the deployer, but you can pass pass in other things. You can pass in network. You can pass in actual accounts, and this will play. So let's go back. Now that we have our migration file, and it should actually look for the file being deployed, we should be able to test. Let's see what it says one more time. I cannot find module exception helper by JS.
It's exceptions helper in the code, but the file is named
Right.
exception singular.
There it goes. Okay. So after all that here, we wrote our tests, and 9 of them seemed to be passing, but 2 of them failed. Great, we got a train coming. So essentially what we want to do is go look at where it said it failed. So if we go take a look, should revert if an address other than the buyer calls receive item. So this gives us a clue that we should be actually looking at that test. So we can go look. So it looks like this part failed. And based off of that, again, we're going to kind of skip through some of the logic that you'd have to spend time debugging. But we can determine that verify caller is not actually doing anything to check this. Or maybe we have it switched around so it's only verifying people that aren't doing it. Or whatever the intended logic is, we've isolated the part that doesn't work, and we now understand that this doesn't work. We can take a look and figure out what we need to do to it to make it actually work. So I think it's require message.sender. And what we just told it is now, assuming you understand the syntax of a modifier, what we have told it to do is anytime it's called, make sure that the message sender, the person calling the account, calling the contract, the address passed in the actual verify caller, where it's actually passed in, this address is the same as the message sender. And now, since we've gone through and saved that, we can go back and we can run, we should be able to just do an test. And now it all works. So essentially what just happened is we, in a very abridged version, we came up with the functionality that we wanted it to exhibit. We put the code in and tested it to make sure that it did do what it was supposed to say. And when it didn't, we used the tests to ferret out the parts of the code that weren't working so that we could refactor them and run them through the tests again to try to get it to work that second time or third time. So again, this is pretty much all there is to developing a smart contract. Once you're able to do this and actually verify that your contract's doing what it says it does, you're like 90% of the way there. And just in case this does close in 5 minutes, I'm going to drop a link real quick.
The meeting was extended to 1 minute.
Yeah, I was about to say that.
Awesome. Okay. Yeah, that sucked last time. Okay. Then we can take our time. Okay. So the last thing that we want to do is we've built this entire application. We've tested it. It more or less does what we want. Now we want to hook it up to our UI. So let's, again, let's assume that maybe we've already developed our UI and we had to make some changes to it and wanted to update it. Either way, we still need to point at the actual contract, so we can take a look at how that is done in context of an actual, so let's close this, an actual React application. So I think what we're at right here is so now we're back in our main file, and let's now we're back in here, and we have added our actual React app. So very quickly, anyone who's wondering how you do that, we pretty much just ran this alongside create React app. You know, that's a whole React thing, but it's really not that hard to use. So we've got our source file here. We have in the package.json, we have the React scripts, you know, NPM scripts set up so that we can actually run them. And that's pretty much all that there is in the way of actually setting this up. Again, stuff that is a little out of the scope of this, but you would need some way to actually get your Web3 variable in. Let's assume that we have all that done. Let's assume that we have an app that is capable of injecting Web3 out of MetaMask, because we do. We have this right here. And in your case, if you went to go build an application like that, you would also have all of this code pre-built at your fingertips. So the main thing that we need out of this would be that get Web3 and the supply chain contract. So this specifically is the last part where it requires some sort of knowledge of how to actually interface with all. So we have got our code in the contracts file, as always. What we want to do is, and you can do it either Truffle build or you can open the Truffle command line and then do build, but we're going to do Truffle build. And this will take the Solidity code and compile it into the bytecode that is run by the Ethereum virtual machine, and is also required, at least the ABI is required to access. Let me let him in real quick. How do I? Sorry, I'm just trying to put some in real quick. Okay. So let's. Okay, we got that. So Truffle build. The ABI, the application binary interface. You know, there's a lot of jargon that's thrown around, and eventually you get kind of keen to all of it. The ABI is one you'll hear a lot. What we just did is we built that ABI along with some other things. And the other thing we'd want to do is, let's say we want to actually put this live. You know, again, anyone who connects to this page and has Rinky Ether, has their MetaMask, can interact with this application. It's live on the internet. And the way we did that, the way anyone can do that, is just by running Truffle migrate network. And this is in that actual, I'm trying to, doesn't say, it just walked up and said, let me in. Doesn't look like it's turned in. So what we can do, again, sorry to bounce around, is we can look at the Truffle.js file. you can see right here when we say dash dash network and we're trying to specify. When we try to specify a network, this is what's happening. If I change this to be network A, then I could say network A. That comes directly from this configuration file. But we do want to specify it according to the actual network we're trying to target. So now we've got, in this, we've got our mnemonic. Our mnemonic has, or the account, the first account in that mnemonic, the first derived path, has ether in it, and we have a valid endpoint we can access, all configured in this file. Then we can do break B, and I think because I already have one up, so if you already have one up, you do just press that. And this will take a little while. This is, blockchains are not known for being fast or efficient. So essentially what it's going to do right now is it's going to run through a simulation to make sure that there are no problems that would make the deployment fail and potentially waste real ether in the form of gas. Whether that be you're missing some files or your contract size is too big. There's a couple of different reasons that you would want to run pre-deployment, which is why it takes so long, or part of the reason it takes so long. Now what it's actually doing is, and you can see this right here, is it's trying to put this transaction in the blockchain. So it added it to the mempool, and someone who's actually validating the Rinky chain picked it up and is currently proving it. And then, after that's confirmed, it will go ahead and do the second transaction or the second contract. So if you're deploying a suite of like 6 or 7 contracts, it can take a while, especially on if you try to do it on Ropsten or even, God forbid, the main chain. It's gonna take a little while. But for our purposes of testing, Rinky is one of the best ones because it is relatively lightweight and doesn't take too long in the way of actually testing all this. So it looks like it's just about done. And what this actually did, besides just deploying it, and we can run Truffle networks, or it's Truffle network. And as soon as this goes through, yeah, so it shows us where this is deployed. That's one way. You can, do it manually, but what we actually have set up, and this is still a little bit manual, what we want to do, and this code is in here. So the first part of the commands, we're going to remove the current ABI that we have in our source contract file, because we need in our decentralized web application, we need to have the ABI somewhere. In source, we have contracts, and in contracts, we have this. So our existing file was already here. First thing we want to do is delete that. That's what that first command does. And then the second thing, which we just did with migrating, was we created, or I guess building created this, and migration appended a very important part to this, which is right here, networks. So we can actually programmatically access the address it's deployed at if we just move it over to the correct area. So that's what that second part does. We're moving this newly built ABI over to that contracts folder. What you do is you go in source contracts. Oh, it already is. Nice. Okay. And then we just copy this, paste this right here. Now we've got it in. So now that we've put this in a place where it's accessible by the web app, React a lot of times will get angry about trying to access things outside of the source. So whether you decide to do it with an automated workflow or you're just manually doing it like I did right now, you're going to have to get it within the scope of the React application folder. But we've done that. We, again, to go down here, we can actually find the network it's deployed to right here for, right there, it's got the address. So with that in mind, and because we can now access that, let's go back into our application. And so we actually do it right here. So we've got a bunch of preparation for Web3. Again, there's some really cool resources on Web3. If you don't understand it, actually getting MetaMask into your app, you know, definitely take a look at those. But what we've done is we've imported, this is purely just a JSON file. There's nothing more to it. We've imported this JSON file. We have taken both the ABI out of it, which is that interface that lets, you know, whether you're using JavaScript, you're using Python, you're using Java, whatever application you're using, it needs a way to drive and communicate with the contract. So we pulled that out. And then beyond that, we need to know where the contract that we're actually trying to drive is. So we pulled that right out of the deployed network or the address as well. So we did that simply by knowing that network ID was 4. I think we have that specified right here. So you can actually get it out of the injected Web3 instance. It can tell, oh, you're on RinkB. So if you decide to build a contract with multiple different networks, you can dynamically have it connect to the correct one if you set it up in this manner. So if you want to have like a live net and a test net, you can do something like that. And all you have to do, again, is just make sure that you've migrated it off of the same file, that it has multiple different networks in here, and you can just access it through JSON and actually determine what you want to get. So now what we've done is we've said, and this is a command to actually instantiate a new contract instance that we can interact with. We've done new web3.eth.contract, put in the ABI, put in the network it's deployed to. I think specifically it's grabbing this. And by having the ABI, the correct network, and the address on that network, we now have everything we need. We can just interact with it. So, you know, we're not going to go too much into all the other interactions, but okay, I guess. Yeah, it's passing. Okay, so once we've got that instance, we can actually use it and drive it, which again goes into Web3. We're not gonna go super in depth there. So that is pretty much it. What we've gone through to just run through it all is we've gone through a supply chain dApp. So, you know, we did all of this in the context of a commercial solution. We set up a brand new Truffle project without any sort of like extra framework. We did copy and paste in some logic, but you know, you could write that logic yourself and step through the same processes to actually build your application in the contracts folder and in the migrations folder. And then we actually came up with a specific context, event, and list of behaviors out of this entire supply chain that we wanted to validate. Obviously, you know, to validate every single part of this would take multiple hours to go over cleanly, but we took a single part of it and showed how we can use behavior-driven development to actually accomplish the task of making sure that we built our supply chain to do what we wanted to. We then actually built and deployed it onto a live network. If we went and looked on the RinkB Etherscan website, we would be able to see it. And if we ran the GitHub pages deploy function, it would actually reflect here, which I'm not going to do because that'll take a minute. But we could actually have it point at a different contract now because we've deployed our new one. And yeah, so that's pretty much it. Before I go into asking if anyone has any questions or if Scott or Amal want to add anything, really quickly, I have to give a shout out to our partners at Blockchain Education Network. They're not like paying MUBC or anything. They've given us a lot of help in the past, and right now, currently, what they're trying to do is an airdrop for their project. So you can read a little more. I mean, you can get like $1 to $100 of Bitcoin Cash, which it's Bitcoin Cash, but you can sell it off as Ether or something. And more importantly, I think, is that you should kind of think of it less like money, getting free money, and more like getting access to potential opportunities in the future. As Ben grows, they might have access to other resources, and having these tokens might be the way you get into it. So, takes a couple minutes out of your day if you're legitimately interested in the kinds of things they're doing and getting more educational resources for cheap or free. I would take a look at that. Other than that, we are going to actually be holding a dev meeting next week. This will be to talk about the MUBC incentive token that we are launching pretty much. I think we have both of our Apple and Google Play Android licenses now complete, so we should possibly be launched. We might even launch during the meeting, depending on how ready it is. But so we'll be running through the kinds of opportunities that there are there, as well as how that kind of funnels into the professional opportunities that we have through the Midwest Blockchain Consortium. That one's not going to be open, so if you do want to attend that, I would just send an email over myself, which is gilcrejp@miamioh.edu. Otherwise, I'll be reaching out to a couple of people I think should definitely come take a look at it. So yeah, this recording will be up on YouTube and eventually added to our website, which still working on that a bunch, but I'll show where you should be able to find it in a minute. You should be able to pop this open, and this will be kind of filled with a lot more than just this boilerplate stuff. It'll have the video, it'll have all our resources, it'll have a bunch of links. So check back here in a week or two, and there should be a lot more. But yeah, thank you so much to Scott and Amal for taking the time to help us put this together. Is there anything else you guys wanted to add?
Yeah. First of all, nice presentation, really good. It was really fast. And I did see something. I have some notes that I'll send you.
Okay.
If anyone has questions, please feel free to reach out.
Yeah.
I like the demo. This was really nice.
Awesome. Okay. And then on the subject of questions, are there any? I know that like was just pointed out, I did go pretty fast. So if you guys decide to go through and try to put this together in your own time as well, and are having trouble, you can definitely reach out to me, and we can go through in a little more detail some of the different parts and try to get it working. But yeah, is there anything anyone from the audience wanted to bring up?
Oh, one other thing, Jack. If you could share the webinar we did, which goes a little more in depth for anyone that's interested, I think it could help balance out what's in this, what you presented, or go a bit deeper.
Yeah, should I drop both of them, the GitHub and the Crowdcast?
Yeah, sure.
Okay. Yeah, this is a lot of what I did was inspired off of this. I did watch it relatively recently, as in the past 4 or so hours. So I didn't have a ton of time to adapt, but I definitely, this one takes little more basic of a smart contract and runs through that. So if you're looking to completely write the application by yourself, this one will be a lot easier to go through. So those are two links. Obviously, you can separate them by the HTTPS, but the Crowdcast. So you're gonna have to like sign into that. It should take like 30 seconds, but that's a recording of a webinar that Scott and Amal and a few others I think did very recently. Pretty much on the same subject with more focus on behavior-driven development and less focus on the supply chain app. But yeah, I would, probably an hour to watch the video and another hour to get actually, through all of the content. Like Amal said, I think there's a lot of opportunity for people our age to get involved and even get employed in the space. So, there's not a ton of, no one's gonna come to you and talk about, hey, they're starting up a blockchain major, at least not right now. So this is the absolute best way to actually get experience working with this technology and potentially getting on the road to making money doing it.
And on another note, we will, I'll send out a link to invite you to our Slack community for Truffle. That way, if you have additional questions, one of the things that we've been kind of advocating for is to eventually get accredited comp sci focus emphasis on blockchain into universities. And so there's a couple other foundations that are doing the same thing. So these types of recordings, webinars are all kind of ammo, if you will, that we can present to professors and anybody else that you have to do these kind of political loophole jump through hopes and whatnot to make it happen. So I love these things. Keep it up. And then finally, TruffleCon is November 6th and 7th. And I believe Jack will put up the link too on the website. That's a free conference. It is virtual. And so there's going to be a lot of great presenters, people that are also showing some great use cases of other supply chain industry, focus on blockchain, healthcare, IoT. So there's some pretty cool stuff that's going to be presented. So we'll look forward to seeing you there. And the platform's going to be Hopin if you're familiar with it. It's a nice kind of networking feature on there as well. So for those who are in a position that want to start looking for opportunities via job, that's a great place to be at is TruffleCon as well. So ping us if you have any questions about it, but sign up, it's free.
Yeah, absolutely. I know I'll be there. Yeah, great opportunity again. Truffle is, if not the largest, among the top 3 or 4 largest tools in the space. So, at TruffleCon, you're going to see the cutting edge of the industry. You're going to see the best of the best talking about what they're doing, and getting potentially involved with those people is a really fantastic opportunity. So. But yeah, I think that's pretty much it. We're rolling right up on an hour. So yeah, again, anyone who has any issues messing around with this, give us a ring, and we will definitely we're here to help you guys build blockchain. So if you guys anyone has any issues or just wants to show something off, there'll definitely be those sorts of opportunities. So thanks for coming out.
Thanks, guys.
Take care, guys. Nice one.
Okay. Peter, you want to just like hammer this out right now? I'm actually gonna disconnect this so that I can finish this call, but I can just like call you on the phone right now, honestly.
Sure. Or call. Let's do I could send you then or something on Google.
Okay.
I'll certainly show you the.
Oh, you want to do talkie.io/MVPC?
Yeah, sure. That sounds good.
All right, I'll see that.
All right.